Let's go ahead and figure out this integral's value to an error of less than 10 to the negative 3. The first thing we notice is that we have a power series for the reciprocal of the square root of 1 plus x. Well, we can modify that power series and get a power series for the reciprocal of the square root of 1 plus x to the 4th by replacing all of the x's with x to the 4th. X to the 4th squared will be x to the 8th, and this one will be x to the 12th, and that will continue on forever. Now, our interval of convergence changes when we do this, or potentially changes. In this case, it's not going to matter, but we need to go through it just to make sure that the interval of convergence includes those numbers. Now, well, let's just do it just to make sure it's clear. So the interval of convergence is beginning like that. I mean, that's not even written very clearly. Let's try again, like that. Now we're replacing x with x to the 4th. This part of the compound inequality is always true. Therefore, this is the only part that is going to give us x values. We can take the 4th root of both sides here. Everything is positive on the left and the right, or non-negative. So we can take the 4th roots of each side. This is absolute value of x, less than or equal to 1. And what we notice is that our interval of convergence is a little different here. Our interval of convergence is going to be -1 to +1, including both endpoints. And you can kind of see why this makes sense. When it's just an x here, you can't plug in -1 because you'll end up with division by 0. But here you can plug in -1. -1 to the 4th is +1, so you don't get division by 0. So at any rate, that is our new IOC for our modified series here. Now let's get to the heart of this. We are going to be integrating from 0 to 0.3. We are going to replace 1 divided by 1 plus x to the 4th square rooted with its power series. So we are integrating 1 minus 1/2 x to the 4th plus 3/8 x to the 8th minus 5/16 x to the 12 plus etc. dx. So let's go ahead and integrate term by term. We will have x minus, we'll have x to the 5th over 5. So we will have 1/10 x to the 5th. Next term will be positive. We're going to have an x to the 9 over 9. So we will have 3 over 8 times 9. We'll do a little simplification in a second. Minus 5/16. And here, when we add 1, we're going to get a 13. So we have 5/16, but we're going to have to multiply by 13. Our power on x will be 13 plus etc. Evaluation symbol, 0 to 0.3. What we notice is that when we plug in 0, everything is 0. Everything zeroes out, so that doesn't contribute. So we'll end up with this alternating series. 0.3 minus 1/10 times 0.3 to the 5th power plus, little simplification here. So 8 times 3 is 24, so we'll have 1/24 times 0.3 to the 9 minus whatever this multiplies to. Let's just leave it for now. All right, so this is an alternating series. And what we know about alternating series is that we can use the first unused term as an error estimation of all the terms in front added together. So this question asked us to round the value of the integral so that the error is less than 10 to the negative 3. So we need to find the first term that is less than 10 to the negative 3. Well, if we plug into our calculator, we see that this value right here will be 0.000243. That is already less than 10 to the negative 3. 10 to the negative 3 is 1 over 1,000, which is 0.001. So what this tells us is that the value of our integral, we can approximate it as 0.3, and that will be within 1,000th of the actual sum. Now, if we went out a little bit further, this term here, if we type all that into our calculator, is going to be that. And so 10 to the negative 3 is, we're only going to use the first term with that error estimate. Look how accurate we will get if we use the first two terms. So if they made this a little more complicated and we wanted to be less than 10 to the negative 4 or 10 to the negative 5 or 10 to the negative 6, we would use this term here as our error estimate, and we would add the first two terms instead of just the first term. But the question said, have the error less than 1 over 1,000? That's it, right there.